Hello humans, welcome back to Code with Connor. This is the Let's Learn Python tutorial series. We are here in topic 5, unit number 3. We're going to talk about two-dimensional lists today, which is awesome. But first, let's go back and look at the challenge from the last lesson. All right, last lesson was the Lib Generator, which we've done before, twice. So here we are. I have a list called word list, and then I'm appending user input onto my word list. So I just added this in front so that they're all getting stored into a list. And then in my actual print statement, instead of referencing variable by name, I reference the same variable, which is my data structure or my list. And then I just went the index, incremented from 0 all the way up to 11. That was the only alterations I had to make to my code to make it work. So it's just a little example of using lists in a system where we had a whole bunch of variables, as opposed to just using individual variable names to do that. Did it really make things that much cleaner? Not really, but it was about practicing and trying that out. For today, we are going to be talking about two-dimensional lists. Okay, we're going to start by doing a really quick little thing about unpacking a list as a variable, and then we're going to jump into two-dimensional. So unpacking just looks like this. So here's an example. I have a list variable, box notation, integers 1, 2, 3. Let's say I wanted to pull a bunch of them out at once and store them in separate variables. That's called unpacking. So I can do this x, y, z, no square brackets. This is not a list. X, y, z is equal to my list. Now notice the number of these has to equal the size of this. So there's 3 of these. This is size 3, so that works. And it'll assign the first one to x, the second one to y, and the third one to z. And then we can handle those variables individually. So if you ever wanted to kind of mass pull out variables from a list, kind of all at one shot, you can do it this way using unpacking. So if we run that and see, right, you can see I printed x, y, z, and it printed those values. And if I change them for some reason, so if this wasn't 1, 2, 3 anymore, if this was like, 0, 12, and -3, and we run that, it all kind of updates. It pulls them from the list, and then they're now stored in the variable. Okay, so that's unpacking. Now we're going to talk about two-dimensional lists. All right, so to understand two-dimensional lists, we need to understand basic row column notation. So if you've at a stage in your life where you've learned matrices before, you're going to be fine. If you've never learned matrices and you're stuck in like Cartesian graphing, it might hurt your head a little bit, but it's not that big of a deal. So the important thing to know about two-dimensional lists, all they are is a list that contains lists. Now, typically we want to work in a rectangular space. So we want to have a list containing lists that are all the same size, but Python does not enforce this. You can have like a triangular or just totally random two-dimensional list where the individual lists that are stored inside of your bigger list are of various sizes and data types and all of that. So it just depends on what your needs are for the list that you're creating. So in this case, I have a board list, which you'll notice double square brackets, but don't focus on the double. Focus on the outer brackets. That's a list. And then what are the elements inside? Remember, comma separated values. This element separated from this element, separated from this element. Okay? Those are actual items in the list. Now, each of them happens to then itself be a square bracketed, comma separated value list. So it's string, comma, string, comma, string. And then this one is string, comma, string, comma, string, and so on. Now, these don't have to be strings. They don't have to be whatever, and they don't have to be the same within the list. And the separate lists don't have to be the same, and they don't have to all be the same size. Just for the sake of learning it, that's how I'm doing it. Now, I wrote a couple of quick functions. I have print board, which says global board, so I can access and modify this global variable. And I'm just printing out this little 0, 1, 2, and then I'm printing out this 0, 1, 2 followed by the entire row of the board. Now, this is interesting. Board box 0 is no longer just a single item. It's an entire list. It's this entire list. Board box 1 is this entire list. Board box 2 is this entire list. Okay? And then I'm doing a change value function where I'm asking the user for a row and column. I'm making sure it's not out of bounds, so it's not smaller than 0 or bigger than 2. Then I'm printing, if it is, invalid entry and do it again. Then I'm asking for a new value to put in that spot. I'm reassigning the value. We'll talk about this RC in a minute. And then I'm printing the board. Okay? Print board, I wrote here, we already saw. And then I have my while true. Press enter to change or Q to quit. Let's just run this and then we'll look at the code a little closer. So when I run it, press enter to change the value. Okay. So row 0, 0, I'm going to put an X. So then it's going to print out my list. So I added these here so we can see the row column notation. Row are 0, 1, 2, and then column 0, 1, 2. Now the way they're stored, remember, is a list of lists. So this entire list is stored in board box 0. This entire list is stored in board box 1. So that row notation represents which list you're in. And then the column represents which element within that list. So column 0, column 1, column 2. Now we can't reference the columns alone. We have to reference the row and the column to get the individual item. So this would be row 0, column 0. This would be row 1, column 2. So let's say I wanted to change that one. So row 1, column 2, and I want it to be an @ symbol. So row 1, column 2 is now an @ symbol. If I try to change something out of bounds like 3, 3, invalid entry must be between 0 and 2. All right, so let's see if we can change this corner to 2, 2. 2, 2, and I'm going to make it an exclamation point. So you can see I've overwritten that value in 2, 2. So this is that row column notation. Row, column. And in order to access an individual item, you have to use both a row and a column. Now you can access an entire row by just using the row value, but you cannot access an entire column by just using the column value. You would have to do separate items that have both row and column because of the way these things are stored in the variable as a list of lists. Coming back into the code, let's go a little bit more explanation on what's in here. So take a row and column value from the user. Make sure row is not less than 0, not greater than 2. Column is not less than 0, column is not greater than 2. If any of these are true, it's going to keep looping. And it's going to print invalid entry, must be between 0 and 2, asks for the row and column value again. Stores the value from the user. So they've now given me a proper index. And then here I'm assigning value. So I'm saying go to the board, go to row R, column C, individual item, and change its value to the value given by the user. And then reprint the board. Okay? In here was just a really quick while loop. While true, temp is an input, enter value change. If they entered Q, break. Didn't even bother with an else, just going to run my code, which is calling this change value function. So this idea, this row column idea, this understanding of a list of lists, this is what's at the key here when we talk about working with two-dimensional lists. Now, the most common examples I would give you is graphics. Right back in the day, we would think about, X and Y coordinates. We did turtle graphics, right? Think of it like a two-dimensional array. Okay, so a two-dimensional list, array, sorry, is more of a Java word, but they kind of mean the same-ish thing. Ish, not really the same, but if you do Java with me, we'll figure that out then. Okay, so we need to have this row column piece down in order to do this challenge because it's going to be a tricky challenge for us. All right, so make sure you practice this, write this program, play with it, make sure you understand it, make it bigger. Can you make it dynamic? So that if these aren't the same size, this still works. So you'll have to get fancy with your Boolean statement. You can't just hard code 2 in there. You might have to do some kind of length thing. Make sure it works. So it gets a little trickier there, but maybe you can do it. Maybe you can make it dynamic and have it actually work for different size lists, but have the rest of this all work. Or maybe the lists are all the same size, but they're bigger and you want it to still be dynamic, but they're all the same size. So you get to play around with that a little bit. You need to understand that before you jump into the challenge today. All right, let's talk about the challenge. This is a big one, so I'm going to run it, and don't get too scared. Just try. It's a maze. So I've printed out my maze to the screen, and I had to write a print function to do this properly, so it doesn't have the commas and all of that. Just nice, neat maze. I filled the border with X's, with the exception of one asterisk symbol at the bottom. I've left space characters where my actual maze pathways will be, and I've put X's everywhere that it's a wall. Sounds pretty good. All right. And I have an @ symbol that represents my character. I'm going to move. How am I going to move? Using WASD. So, S. Hey, it reprints my maze. My @ symbol is down. Let's try S again. Ooh, invalid move. Did not move me. Okay. I'm going to start moving here. If I try to go into a wall, it should tell me invalid move. If I don't, it should allow me to work my way through the maze. And then when I press my S and I go down, it should recognize that I hit the asterisk, win. I get a nice you win message, and then it quits the game. Now you could add an extension here where when you win, it asks if you want to play again. If you say yes, it clears the thing, starts it over, but that's not necessary. You're going to have enough of a trouble just getting the collision piece, making sure that you can move through it, drawing out a little maze, all of that stuff. It's all going to be part of the process. This is not an easy challenge with the small amount that I've told you with 2D lists. It's going to take you playing around with it. It's going to take some frustration, but it's going to get you to a point of understanding, which is really what we want. So go there, try it, see what you can do. Share with me in the comments what you think or what you've achieved, and we'll see you back here real soon. Don't forget, if you like what I'm doing, like, share, subscribe, and we'll see you back for topic number 4 in a little bit. See ya.